Okay, in this section we're looking at the volume of pyramids and cones, and keep in mind a pyramid and a cone, they have some things in common. They both come to a point and they both have one base. And if I was in class I would kind of show you this, but if your cone, let's say, has the same base as a cylinder, as well as the same height of the cylinder, notice it's going to take up less space. It actually takes up a third of the space. And so that's how we get the volume of a pyramid or a cone, is it's 1/3 big B, which is area of the base, times the height. And just remember your height has to be at a 90-degree angle. It's really your altitude, your 90-degree height. The only time we use the slant height in honors geometry is finding the surface area of a cone in a formula. So you might use it to find the true height, but we always are going to, H is just representing the altitude or the true height. So let's look at example 1. We're finding the volume of a regular hexagonal pyramid with a base edge of 2 centimeters. So all of these sides are going to be 2 centimeters since it's regular. So how do I find the volume of a pyramid? Well, it goes to a point, so it's going to be 1/3 area of the base times the height. Well, the base is a regular polygon. It's a hexagon, but we'll just call it a regular polygon. And then I need to multiply by the height of the pyramid. So many of you might find the area of a regular polygon using the formula, and you can find the area of any regular polygon with 1/2 the apothem times the perimeter. Now with a hexagon, you can also, split it into 6 congruent triangles, which I'll probably show you also. But if you're wanting to use a formula, it's 1/2 the apothem times the perimeter. So I went ahead and pulled in the base here, which is a hexagon. So what I need to do is I need to find this apothem. Okay, well, there's a few things I know. I'm going to highlight this in red. I know that this red length right here is 2 centimeters. So when I cut it in half, that means this green portion is 1. Now I'm going to draw in some lines to help us out. So just as a review, let's say that I looked at this yellow triangle right here. I could actually draw in 6 of those in a regular hexagon. And so I mention this because that really just helps me know some of the degree measures. So, in a circle, right, you're going all the way around a circle. So I'm going to draw that little yellow triangle over here. If I have to label, this is going to be 60 degrees because all of these right here would be 60 degrees. Because when I go all the way around the circle, that has to add up to 360. So when I split that 60-degree angle, that now becomes 30. So I'm just gonna put a little arrow here. This is now a 30-degree angle. So I'm gonna highlight, I think in purple, this smaller triangle that I'm going to actually use because I'm going to use it as a 30, 60, 90. So I'll highlight it in both places so that you can see what I'm looking at. So I know that this length is 1 because this other part is 1. And I know that I'm dealing now with a 30, 60, 90. So that 1 is opposite of that shortest, it's opposite of the smallest angle, so it's the shortest side. If I needed to find this hypotenuse, I could just double this. So it'd be 2. And you don't really need it, but just as a review for 30, 60, 90, the hypotenuse is double the shortest side. And then the middle side, which is right here, is going to be 1 times root 3, because the middle side is always the shortest times root 3. So what that is I'm going to highlight this in blue. Maybe I'll do orange since I haven't used orange. So I'm going to highlight this in orange. So on both diagrams, the apothem is what is root 3. So that's going to now help us find the area of the regular polygon. So if I use the apothem as root 3, then I could use the perimeter. Well, we started by saying this is 2, all the way around that regular hexagon. If I add up those 6 sides, is 12. So I can do 1/2 of 12 in my head, and so this is going to be 6 root 3. Now that's just the area of the base. Okay, that's just 2 dimensions. I still need to consider the height of the pyramid. Well, notice it says the height is equal to the area of the base. Well, we just found the area of the base, didn't we? We just found this hexagon, and we know that the area of the base is 6 root 3, so we're going to plug in 6 root 3. So I found the area of the base times the height. That's the 3 dimensions, because area is 2-dimensional, and then the height is the 3rd dimension. And then since it comes to a point, I can't forget that this is 1/3 area of the base times the height. Well, if you were to do that multiplication, that's something you probably should be able to do in your head. Let me move this up a bit. So you're doing 1/3, and then 6 root 3 times 6 root 3 is really 36 root 9. Well, 36 root 9 is really 36 times 3. Hopefully you can do 1/3 of 3 in your head. 1/3 of 3, if you have $3 and you take 1/3, you have $1. So that's going to simplify to 36. Now it is a volume, so I need to say centimeters cubed. And there's my answer.